All right, so in this question, we have a current of a river being 5 miles per hour, and an Anch drives a boat that goes 240 miles downstream in the same amount of time that it can go 160 miles upstream. And it's wondering, what is the speed of Anch's boat in still water? So let's go ahead and first just break down information that we need. We have the current of a river is 5 miles per hour. And then Anj can drive a boat that goes downstream 240 miles in the same amount of time that it can go 160 miles upstream. And we're looking for the speed of Anj's boat in still water. So we're going to break this distance question into two different parts in our table. So we have downstream, and then we have upstream. And so then we have again our distance, our rate, and our time. So downstream, we know it can go 240 miles. In that same amount of time, they can go 160 going up. Now, to figure out the rate, just like I did on the previous example, we're going to go ahead and draw a bit of a picture. So we have our river right here. So rivers, generally, they're going to flow. If it's going downstream, it's going with the direction. If it's going upstream, it's going up. So right now, this river on its own, it has a speed of 5 miles per hour. Now, we are trying to figure out what the speed of Anch's boat is going to be. And so the boat on its own in still water will have its own speed. Now, whether we're going with or against the current kind of determines things here. So if I'm going down the stream, that means I'm going to be going with the current. So that means my boat is going to be going faster. So Anch's boat, which we don't know the speed of, we'll say is X. When it goes down the stream, it'll be X plus 5 for the 5 miles per hour of the stream. Now, if it's going upstream, that means it's going to be going against the current. So the arrow will be going up this time. Still is going to be X because we don't know what it is because it's the same speed of the boat, but it's going to be pulling against it. So that means it's going to be going slower, so it'll be X minus 5. So again, this is just base relative off of where it's going up or down the stream. And so that's all the information we have, but we know that these two trips are going to be the same, take place over the same amount of time. So I can go ahead and calculate what my two times are going to be based off my distance and the rate, distance and the rate, and then I can go ahead and set those equal to each other. So again, like we know, distance is equal to rate times time. So that means that time is going to be equal to distance divided by my rate. So I'll take 240, divide that by x plus 5, and I'll take 160 and divide that by x minus 5, like I said before. And we're going to go ahead and set those equal to each other because, again, it says the same amount of time. So I will have 240 divided by x plus 5 is going to equal 160 divided by x minus 5. And so I'm going to go ahead and solve this by cross multiplying here. So if I do that, that will give me 240x minus 1200, because again, I have to distribute this, is going to be equal to 160x plus 800. Distribute that one as well. And so now I'm just going to go ahead and solve for x. So I will get 80x is going to be equal to 2000. So then x is going to end up equaling 25. And so again, just to check, it's asking for the speed of the boat. X represents the speed of our boat in still water. So our answer will be 25 miles per hour.